So say we wanted to look in a little more detail at one of the proteins in here. We're already looking at this RPOH. I think we stepped through this page a bit. Like any of the other landing pages here, we've got all of the information available about this protein. Rebecca was looking at the spreadsheet that had the location information, and that's available here. You can get the accession for the sequence links. If you want to copy and paste the actual sequence itself, the quick way here, you just click on that and you can get the sequence if you need to copy and paste it into something else. I've got information about the protein families. Actually, so you can go through, and we have sort of protein family landing pages. It'll bring up this protein feature list that has all of the members of this global family. This will tell you some things. It's sort of interesting. You see that this is a large family. We've got 269,000 entries in it. In the feature list view, you can also get overview figures. They're not going to be very interesting. They're all going to have the same function because by definition, every feature in a protein family has the same function. So let's go back. What else do we have on here? We have some links to other external tools if you want to poke around. These will bring up these external sites with the information filled in. Go look at domains. The thing we're going to talk about now is the Compare Region Viewer. We sort of get this cartoon of the region of the genome here where we can see it in relationship with the other proteins in the genome. But with Compare Regions, we'll see the feature in the genome in comparison with other genomes in the system. So this is a very busy diagram. I'll just sort of go through the general structure of it. Each row is a genome labeled with the genome name over here on the left. The protein features are arrows. These blocky features that don't have arrows or any other feature type. For instance, this is a repeat region. We mentioned when Jim was talking about the genome annotation, we compute repeat regions by blasting the contigs against each other. They'll show up here. So this is sort of an interesting area where we've got a number of end-to-end repeat regions. If you click on something inadvertently, you'll get a window with the details of the feature. And again, you can grab the sequence, and this is basically this information that was in the left-hand side of the feature page. And if you so desire, these links are all hot. You can go click on these and go off to further explore. The colors are the protein families. If you see up here, we have the parameters of the compare regions, where we've got region size is the horizontal size of the display. So we're looking at a 10,000 base pair region. If we want to zoom out a bit, I can change that. Click the update button. This gives us a more global view. And we've chosen 10 genomes, so that's the height of this display. So it will go through and choose 10 genomes to display. The genomes are chosen using the method here. So we're using the PGFAMs to choose genomes. The way this works is that we look at our focus feature. The other important thing is that this display is organized around a single feature, who's what we call the focus. So we take the focus feature, we look at the members of its protein family. Remember, when we clicked on this before, there were some 269,000 members of the family. So we do a quick estimate of the features in there. We grab a subset. For these very large families, we'll grab the random subset. In one of the upcoming updates, we're going to be keeping a set of representative features for each family that will give us sort of a broad coverage over the family. We'll be probably switching to that for this. But for now, we just pick a set of them, and we compute a blast between the focus feature and the sort of set of things we're going to put in the pin, and down select to say that these top 10 that we want here. And again, I can increase this number if I want to see a larger swath through the space. Going a little further afield here. We also have these rounded features here that don't look like anything else. What these are is a representation of the region that was, remember I said we blasted this focused against all these other genomes to find the matches. The round blot is a measure of where in the feature the blast hit occurred, and the color is a measure of how strong the hit was. So this base deep red is our focus, and we see these lighter reds mean that these are less strong blast hits. The length of the hit is sort of consistent across these. So the blast is hitting across the entire length of the corresponding features in this pin. So notice that we've got these little numbers here. Again, because we're looking at PGFAMs, we are sorting all these features into groups based on family. The number is a set number, so that all the twos are going to be the same family, and they're all going to be colored the same. You notice that the colors get a little funkier down here. Basically, we run out of easily distinguished colors. So when we run out of the first set of colors, we color the bottom half of the arrows.
And if we run out of those, we start coloring the top half of the arrows. You really see this if you've got these large displays, you'll see that. If we zoom in tight, we'll see mostly the bold colors because we can cover all the colors here. You can also see here, since we zoomed in, that this blast hit, we only matched the slattered part of this protein because it was not a complete hit. You'll also notice that the arrows are on multiple different lines. That's just anytime we have an overlap, we will spill these features onto another line so that we never render anything overlapping on the line. So there's no real meaning in which part of the line feature is in. It's just wrapping around. I mean, it's done a little bit inconsistently at times. Sometimes you'll see the blast hit be on top of the feature. That's just how it ended up. So notice that there's nothing really close here, right? I'm looking at Ricea, but my closest hit is a Schuenella. That's sort of uninteresting, maybe if we're interested in the Ricea. This next item here we see is that the Genomes tab has the choice of genomes that we're looking at. So right now, for performance purposes, we look at the reference and representative genomes. We can switch this to look at all genomes. And for grins, let's go up to 50 here. And this will widen the scope of the genomes that we'll choose to put into this display. We'll see if we hit anything a little closer here. We pulled in a couple more endosymbionts here, which is sort of interesting, but still nothing that's what we were looking at earlier. And remember, the analysis we were doing before was in the context of a set of Riceas, right? So one of the other choices here is that I can select the genome group. The wrapping here is weird. We haven't fixed this up yet. This spills over to this next line. This first drop down here is the genome group chooser. So I'm going to pick one of these Riceas. We'll take this guy. And again, I click update. So what I've done here is limited the scope of this display to just the genomes in this group. So now I see our now familiar set of Riceas here. Let's zoom this back out a bit again so we can see what's going on. You notice the display is much quicker now because the system doesn't have to do this wide search for a set of genomes to match. I'm telling it the set of genomes that I want to look at. And we can see there's common structure here now, right? Which we'd expect because we've got this context. And we see that a number of genomes have these repeat regions in them, which is sort of interesting. And we can see that these two guys, the order is swapping. So that's sort of interesting too. To a biologist, I presume that's meaningful. And again, into talking about doing publications, we can export this as an SVG as well. I click the export button and now it is an SVG, so I can zoom it in arbitrarily. So this could be dropped into a publication. The display retains the order of genomes that are in this genome group, so that if you wanted to carefully order them along the tree basis or whatever, you can do that, and this will correspond. Notice that there's no genes in this feature region over here. If you look carefully, there's a little stop point on here. This is the end of this contig. So you can see that this guy is truncated in comparison to the others, which also could be meaningful as well. If you want to see, you can zoom all the way out and get some feel for the overall large-scale structure of this set of genomes. Back here. If you want to explore, you can double-click on the features, and that will recenter the display on the feature that you've just chosen. The new number one is our focus on the thing next to what we were at before. And we're still looking at the same set of genomes because we're still locked into our genome group of a set of 9. So say this is really a broken up section here. What's going on down here? I can double click on that guy. I got nothing. There's glitches you can run into sometimes. What that may mean is that we didn't actually have any matches to that guy. This protein is white, which means that there were no blast hits. So even it looked in this set of genomes in the genome group and it found no hits for that feature. And that's it, again, something that you may run into. And it's just sort of interesting. You can click around and see what we've got in the set of genomes to get just a feel for what these look like. And again, I clicked on this one. I only have 5 hits here instead of the 9 or 10 that were in the set. Another way we can get into this, remember we were looking at our genome groups. So let's go back. Let's go look and see what kind of feature groups here. Oh, here we go, Ricea genes. This is from this morning's talk. I'm going to view this. So again, we're in our feature group view. Click on the features. Notice that there's a Compare Region Viewer tab here on the feature group. And I can click on this. And this is going to be goofy because if you look at this,
These are features in one genome, sort of along the genome. And so if you look at compare regions here, you're not going to get matches because we're not looking at the same feature across a set of genomes. We're looking at a set of features across one genome. So it doesn't really make sense to look at this here. And you can see that it's got a bunch of hits because here, if you're looking at a feature group, it's again not computing what your matches are. You're telling it, I want to look at these features and comparing to each other. And we get essentially no clean hits against them. You know, it does give us blast hits, but they're plain white blast hits, and the size is just the size of the feature here. So the blast hit in this case doesn't really mean anything. I believe that's all I've got to say here. It's a fairly simple tool to use, or at least we hope it's a fairly simple tool to use. We view it as an exploratory tool for large things. And we're going to be doing things I'm planning on doing is be able to use this tool for doing selection of genes, right? Because in the same way that in the heat map view, you can draw rectangles around sets of map hits in the heat map view. We want to do the same thing here, create new feature groups right out of here to do further analysis on. It's further integrated with the rest of the system.
Can you click on a feature and then go to the feature page?
Sure. So say we're interested in this guy. So I've got my feature summary. If I just click on the link here, so I'm back at this page, and we can start the process all over again. So I'm going to go look at the global family that this is involved in. I'm interested in this family, and I want to compare a set of these genes. It doesn't make sense to put up a compare region viewer of 450,000 features. If I clicked on this tab, it would try and do it for you. I'm not going there. It will try its best and may take a while. But what I can do is select a subset of the features here. If you select a subset, you can click on the features list. I know we've created feature groups and then looked at the groups, but you can just go click on the features list and you get another page that's a view of just these features. And from here, you can go directly to the compare regions. So this now makes sense to look at. Remember how we got here? We plucked a random feature out of the last display, we went to the feature page for that, and then we went to the global family and plucked a subset of gene features out of the global family to look at, and now we can see that we've got this interesting view of a set of genes from the global family.